So today we are going to solve inequalities with variables on both sides, and we're going to try to eliminate this set of parentheses. Well, when we do that, a lot of people want to subtract the 2 from this 3 and get 1, but that would be a mistake. We don't want to do that because order of operation says that we have to multiply before we subtract. So what we're going to do is we're going to take that negative 2 and we are going to distribute it over that addition. When we do that, we're still left with this 3 minus 2x and then a minus 8. And there's another mistake people make. Sometimes they just bring down the sign, but we're multiplying a negative by a positive, so we're getting a negative 8. I'm going to bring down this inequality sign and the 4x as well. Well, from this point, we need to collect like terms. So we need to combine the 3 and this negative 8. Now, some people want to do opposite operations, but we can't do that because we're on the same side of the inequality sign. So if we were to combine these, we look at the signs in front. This is a positive 3, this is a negative 8. We subtract these two numbers because they are opposite in sign. So here we're left with a negative 5 minus 2x is greater than or equal to 4x. Well, from this point, we need to isolate the variable further by doing an opposite operation. And here's where we're going to end up doing that opposite operation because we're trying to cancel out the 2x on the left side. And we do that by doing that opposite operation because 2x minus 2x makes 0. Well, if we do something to one side of the inequality, we must do the same to the other side to keep this in balance. So now we've done that, and we still are left with that constant on the left-hand side. Negative 5 is greater than or equal to 6x. Well, from this point, we need to divide by 6. And that will cancel out the 6's on the right-hand side, the coefficient next to the variable. But again, what we do to one side, we must do the same to the other. So now we've got ourselves a fraction. Negative 5/6 is greater than or equal to x. Notice I didn't switch the inequality sign around because I divided by a positive number, not a negative. It doesn't matter whether the constant's negative. It's only if the coefficient is negative. So sometimes people want to write the problem with the x on the left-hand side, and negative 5/6 on the right. Now if you do this, you've got to be careful with the inequality sign. You see how x is less than or equal to negative 5/6. Well, if we put the x on the other side, we also have to make sure the inequality sign matches. So x has to be still less than or equal to negative 5/6. So if you bring the x to the other side of the inequality sign, the inequality sign will have to revert as well, change to the other direction. Well, we'll go ahead and graph this. Put negative 5/6 on the left-hand side, and we'll put a smaller number on the left to the left of that. We'll put negative 1 here, and we'll put 0 way out over here. And then from there, we'll go ahead and draw a solid circle showing that negative 5/6 is a solution, but also all the values that are smaller than it are solutions. So numbers that are going to the left, like negative 1, negative 2, and so on. Let's take a look at one more problem. And we'll start with another one very similar to this one, where we have a situation in which we need to use that distributive property. Let's try 6 minus 2 times by 5x minus 3. And then we'll go with a minus 2x is greater than 3x. So we need to use the distributive property again to remove those parentheses. So we don't want to subtract, as I had talked about before. Do you remember why? Well, it's that order of operation. Order of operation says to multiply. That's what we're going to do here. And so we're going to multiply first because we need to undo the parentheses. Can't subtract first because order of operation says to multiply first. Well, what we've got now is the 6, which is still there, and a minus 10x, and then a positive 6. Why is it positive? Well, negative times a negative is a positive. So I underline, or I put an arrow to that, because it's a common mistake. People just bring down that sign. You've really got to watch the signs when you multiply. Well, you're going to bring down this negative 2x, greater than symbol, and that 3x. Well, from this point, I want to collect some like terms. So I'm going to take the constants, the numbers without variables. They're on the same side of the equal sign. So I just collect them. That's what we do when we simplify. We just collect. We're not doing opposite operations because we're not going from one side of the inequality sign to the other. We just look at the signs in front. If they're both positive like they are, that means we're going to add them together. When we add them together, we end up with 12. Well, we're going to do the same sort of thing with the variable terms. Now, since the variable terms are different, I'm going to put a different shape around them. Rectangle around that one. Let's put a rectangle around this one. Now notice I'm putting the rectangle around the sign. Always looking at the signs. They're both the same sign, just like the 6's were. But this time, instead of both being positive, they're both negative. So that means we add those two numbers and we get a negative 12x. Bring down the inequality sign and that 3x as well. Well, from this point, we just need to isolate the variable. So we're going to bring that 12x to the other side by doing an opposite operation. So that's a minus 12x. I'm going to add 12x to both sides. So once I've added that 12x, bring down this other 12, bring down the inequality sign, combine some terms. I've got myself 15x is less than, because it points to the 15x, is less than 12. Well, we've got one final step to get x by itself, and that's to divide by 15. So we're going to do that on both sides. Now, as I see this, 15 is bigger than 12, so that means I'm going to have a fraction. But what I want to do is reduce that fraction. So if I see a common factor, like I see 3 goes into both those numbers. I'm going to reduce it by 3. And when I do that, I'm left with 4. So I'm left with this 4, and it's over 5, because 12 divided by 3 makes 4, 15 divided by 3 makes 5. It's still greater than x, because again, I did not divide by a negative. Now again, most times we're going to end up seeing it with the x on the left and the constant on the right on a multiple choice test. So let's make sure we can write it that way as well. X is less than 4/5. So you see how it points towards the x. I need to make sure the inequality sign points towards the x. I put the x on the other side. So if we move the x to the other side of the inequality sign, we also must switch the inequality sign. So let's put that 4/5 in the center. A number bigger than 4/5 is 1. A number smaller is 0. we're going to go ahead and put an open circle on that 4/5, and since x is less than 4/5, we are going to draw an arrow to the left. Well, that concludes part 2 of this lesson, and we are going to move on to solving some inequalities, again with variables on both sides, but we're going to be dealing with absolute value and compound inequalities in the lessons to come.